All right. Welcome. One second. All right. Sorry about that. Had to correct some things with the speakers. Welcome back. This is lecture 4 of Econ 300. Now we're going to continue with the demand side of things. We're going to continue with our theory of the consumer. We're going to get a little bit more into some more rigorous analysis using this Econ 300 level material. And one of the main things that we're going to do in this lecture here is connect. We're going to connect some of the topics that we saw in Econ 200 or wherever you took principles of micro, and we're going to bring them up to the Econ 300 level. In principles of micro, you were kind of just presented with things, presented with a big collection of facts, and were told that they were true, and you had to do things or make analysis and come to conclusions from them. Here, we're going to give you a little bit more, I'm going to give you a little bit more of the mathematical background of why these things are true and where do these things come from. All right, so let's begin. Today, what we're going to look at is, like I said, we're continuing with the theory of the consumer. So the first thing we're going to do is derive the demand curve. All right. One of the fundamental things that we saw in Econ 200 or wherever you took principles of micro was that we had a demand curve which was downward sloping. All right. Today we're gonna see where does that come from, and then we're gonna look at some extra analysis, some things that you might remember from Econ 200 with regards to elasticities. But we're gonna go into a little bit more detail in this lecture and at this level. All right. I will be using a mix of the Landsburg and the Perloff book. It's gonna be mostly the Perloff book for this one. Kind of deviating a little bit from what I have on the syllabus schedule. Um, but everything's gonna be self-contained here in my lecture notes. So I think this presentation of the material might work a little bit better given the time constraints for this class. All right. So let's begin with deriving the demand curve. All right. So as I said, all right, in the last lecture, in lecture 3, we saw the consumer's problem, the theory of the consumer, and how the consumer solves this utility maximization problem. All right. This is a fundamental problem in our economic models. All right. We believe that, or not believe, but we need our model to maybe not even need, let me walk that back. To get a framework for how people make decisions, we must assume that they abide by something, all right? And in the lecture 3, we presented the very most simplest mathematical framework for how we model a consumer's behavior. And that was through the consumer's problem, the constrained consumer's problem, otherwise known as the utility maximization problem. All right. Now that was all nice and neat and cool and mathematical, but how does this connect? How does this even relate to what we saw in Econ 200? Well, we're about to find out. All right. So consider this situation. All right. Assume your preferences are given by the log utility, by this utility function. And suppose you have $12 to spend on two goods, X and Y. The price of each is $1. So this gives a budget line of, remember, when we look at these graphs, we have this is your quantity of your good Y and your quantity of your good X. All right. So if we have $12 to spend and both goods, good X and good Y, cost $1 each, then the equation for the budget line is going to be Q of Y is given by 12 minus Q of X. All right. So what happens if Q of X equals 0? Right? If I'm buying none of X, then I'm buying all of Y and I would get 12. And that's this intercept here. The reverse is true. If I buy 0 of Y, that means I'm buying 12 of good X. So 12 minus 12 is 0. And that takes me to this intercept here. So clearly this black line is where we're starting at. All right. The situation as I've presented it to you is represented by this black line here. Then consider now what happens when the price of good X rises. All right. If the price of good X rises to $2 a unit, then remember, how did we get our intercepts? Was our income Y over the price of the good. So here it was 12 over 1. Now, if the price of good X has increased to $2, all right, instead of $1 per unit, it's $2 per unit. Well, then now if we do income divided by price of X, we get 12 over 2, and we get an intercept of 6. If we did this same thing again, suppose the price increased again to $3 per unit. Then the new intercept, of course, is going to be 12 over 4. Sorry, getting ahead of myself. 12 over 3 equals 4. All right. We're holding the price of good Y fixed. It's hard to evaluate things when there's two moving parts at once. So we only want to study one thing moving at a time. So the price of good Y is fixed. Our budget, the money we have to spend, is fixed. And our utility function, our preferences are fixed. The only thing that is changing is the price of good X. All right. So one of the things we saw in earlier lectures was that as the price of a good rises, we see that the budget constraint rotates inward. The budget line rotates inward. All right. That's good and well, and we already knew how to do that. We already knew how to redraw our budget lines when things change. But how does this affect the optimal bundles? All right, how does this affect what our consumer is going to do? Well, I leave it here. I make a little note as it. I make a little note of it at the bottom that as a challenge, you can use lecture 3, the stuff we saw in lecture 3, to try and derive what I'm about to tell you. But let me just give you the optimal bundles. All right, well, let me just tell you what the consumer would choose at each of these three scenarios. All right, so if we were in scenario 1, back on the black line, then the consumer would roughly right here, right here. Sorry about that. If we were in scenario 1, this would be the first point that they choose. Call this A. All right. If the price in scenario 1, the price of both goods is $1. All right, so we're back to $1 a piece. So what would the consumer choose? Due to the preferences that they have, the consumer would choose 6 of good X and 6 of good Y. And so it comes to this point A. All right. Now, if the price increases from $1 to $2, then the consumer, instead of consuming 6 of good X, that he or she would consume 3 of good X. All right. And that is going to be represented by right here by, we're going to call this point B. And we're going to say point B is, we're going to say is roughly right here. Let me make it a little bit more level. The graph is not to scale. Well, the lines are, but my points are not quite. So we're going to call that B. All right. And the consumer consumes now, instead of 6 units, the consumer only consumes 3 of good X and 6 of good Y. All right. They still spend all 12 of their dollars, but now they buy a little bit less of good X because it's more expensive. Finally, if the price increased one more time, now the good X costs $3 per unit, then our consumer would only want to buy two of good X. And so this would bring us to this point, which I will call C. Now they would buy 2 units of good X and 6 units of good Y. All right. Something kind of that you might notice is that they buy the same amount of good Y, but it's only good X that changes because good X is getting more expensive. All right, the price is going up. This isn't always true, but the reason why we're getting this is because of the preferences that I chose. This log utility is the nicest one, and it has some pretty nice properties. In fact, if you're clever enough, then you will catch maybe some patterns that have to do with this log utility. I don't want to reveal any secrets, so just see if you can deduce why this is working out the way it is. And if you want to challenge yourself, like I said, solve the consumer's maximization problem given these three different budget constraints. And you will find that these are the optimal bundles, and then maybe that might clue you into the patterns that I'm referring to. So let me just make a note here that the optimal bundles are A, 6, comma 6, B, 3, comma 6, and C, 2, comma 6. All right, very good. So this is cool. All right, now we're combining the rotation inwards of the budget constraint as the price of good X goes up. And we're seeing that the quantity demanded of your goods changes as the price level changes. This sounds obvious saying it out loud, but it's nice to fit all of this to fit something that is obvious into a mathematical model too. All right. So, given that, let's plot looking only at good X. All right. Quantity demanded of good X. Let's plot as points the quantity demanded of good X at those three price levels. So remember, at P of X equals 1, we saw that Q of X equaled 6. At P of X equal to 2, we saw that Q of X is equal to 3. And we saw that at P of X equal to 3, we had that Q of X equaled 2. So this is where we're going to make the connection to principles of economics. All right, the very first micro class that you took. So from the above, we had these very simple cases of budgets. All right, $12 to spend, and then we're only changing the price of good X. Now, and then using the stuff we saw in lecture 3, we can find these optimal demand bundles, points A, B, and C. How does this connect to what we saw in principles? Again, in principles of econ, you would see something like quantity on this axis, call it quantity demanded of good X. And then you would have price. I'm sorry, I did this backwards. Truthfully, let me pause here. Truthfully, it doesn't matter. The things will look the same, but I want to show it in a way that is identical to what you saw in your principles of micro class. So if we put price on the y-axis and quantity of X demanded on the x-axis, then we can plot our points. All right. And the points I want to plot are right here. So when price is equal to 1, then the quantity is equal to 6. And we'd get a point something like this. All right. And then when price is equal to 2, quantity is 3. So when price is equal to 2, quantity is 3. Let me make that just a little bit better. Being exact is not so important. What is important is this big picture that I'm about to show you. Finally, at a price of 3, quantity was 2, is 2. And then if I were to draw a line through these points, let's see if I can do, see how I can do. Hmm. That's roughly it. All right. Being exact is not so important, but what do we see? This is the demand curve. This is exactly what you saw in your principles of micro class. We saw that as the price went up, the quantity demanded was quite low. As the price goes down, the quantity demanded goes up. This is what we saw in principles of micro, the downward sloping demand curve. This is exactly where it comes from. All right. The downward sloping demand curve comes exactly from the constrained consumers problem. All right. The utility maximization problem. This is where those demand curves came from. It was easy to introduce intuitively, right? That you're going to demand less of something if it's more expensive. But here in Econ 300, now we're seeing that this is the mathematical basis for it. That not only is this intuitive and makes sense, like what we'd expect to see in real life, but we can actually put this into a mathematical model, how our people make their decisions, right? Things are more expensive, you're not going to buy as much. But if they're pretty cheap, then you'll probably buy a lot. All right. So, like I have here, this shows how to derive the demand curves that you saw in your principles class. All right. And then what did we notice? I just want us to take note here. Let's get this. One, first and foremost, the most obvious is demand is downward sloping. And by that, I mean that Q demanded increases as price decreases. What I've plotted for you, this is what I wanted to make a note of. What I've plotted for you was price as a function of quantity. You can get the exact same thing if you just invert the function. This is what you'll see in higher level econ. You'll see quantity and possibly even in this course, depending on how I decide to show it later. You just take the inverse of the function and you'll get quantity as a function of price. One more thing that I want to point out is that when price changes, all right, when the price changes, your principles of econ teacher should have made a big deal about this, that if the price of good X changes, then we move along the curve. All right. This doesn't shift the curve, but if the price of the thing changes, you just move along the curve. The curve stays in place. It just takes you to a different point on this curve. All right. So in price, I should be specific. Price of good X changes. This results in a movement along the curve. All right. That part is going to be important. We need to make sure that we have that distinction down. All right. Price changes of this good is a movement along the curve. Other things, non-price factors, are what shift the curve. All right. But we'll see more of that later. So that derives the demand curve that we saw in principles of micro. And we have the same results that we saw in principles of micro, but now we know their mathematical origins. All right, so we're a little bit closer to having a firm grasp of economic theory. All right, and again, this is the theory part. We need to build up a theory. We need to build up equations so that they may be tested. And testing is the ultimate goal here. We want to test things to either confirm or reject them. If we reject them, then we can improve our models to make them more like real life. All right. But we need to start with the simple. We have to start somewhere. And that is the whole point of this course. All right. This Econ 300 is giving you the somewhere to start from. All right. Before we go on further, I just want to make a few notes about something very important here. Um, so far, I've only worked with Cobb-Douglas utility, and then just now was log utility, although we didn't use that. We didn't do the utility maximization problem. I didn't do it in front of you. We've seen Cobb-Douglas and log utility. These are very nicely behaved ones, but there are others, all right? And two very important ones are ones that you have heard of in your principles of micro class, but now you're going to see what those look like in more formal analytical economics, mathematical economics, all right? So we need to know, what does it look like if two goods are perfect substitutes and perfect complements, all right? Just as a refresher, consider Coca-Cola and Pepsi. Right? For most people, these two things are more or less interchangeable. If some schools are all Coca-Cola schools, I think I'm probably gonna get this wrong, but UW is a Pepsi school. All right. Interestingly enough, UW or colleges in general will enter contracts, and you'll either have all Coca-Cola products or all Pepsi products. And I believe UW is a Pepsi school. This kind of works the same way with athletic departments. Like your school's football team is going to either be a Nike school or an Adidas school. All right, UW is an Adidas school. Or there's Under Armour schools as well. And then there are Air Jordan brand schools, but those are owned by Nike. So, but back on track to what we're talking about. Um, Consider Coca-Cola and Pepsi. All right. For the most part, unless you're a brand fanboy, then you don't really care which soda you get as long as you're getting something to drink. So if these are one for one interchangeable, then we consider these goods perfect substitutes. I can substitute one Coca-Cola for one Pepsi. It doesn't matter to me. It gives me the same utility. How do we represent this in a utility function? It's the simplest possible one. It's just linear utility. All right. So if I only had 1 unit of Coca-Cola and 0 units of Pepsi, all right, imagine this is 1 and 0, then 1 plus 0 is going to equal 1. On the opposite, if I only had 1 unit of Pepsi and 0 units of Coke, I still get the same utility of 1. So this is the very essence of perfect complements, and this is how we model them with a utility function. This is how we model them in an economic model. All right, so linear utility represents perfect substitutes. Okay. In general, um, maybe you don't value things exactly one for one, but so just hypothetically, suppose that maybe you are, maybe you like Pepsi a little bit more, and and I'm sorry, maybe um, I think I have a typo here on the slides, so let me cross something out and I will edit it. Let me right here, right here. There we go. This might be okay, but let me say it out loud first, and then I'll decide if I'll put it back. Okay. So instead, suppose that, remember X is Coca-Cola, or in this example, we're going to call X Coca-Cola. So maybe we like Coca-Cola a little bit more. All right. If we like Coca-Cola a little bit more, then 1 unit of Coke gives me, suppose I got 1 unit of Coke and 0 of Pepsi, then my utility would be 2. On the other hand, if I only had 1 unit of Pepsi and 0 of Coke, then my utility would be 1 in this case with this utility function. What this is telling me is that I get more utility out of Coca-Cola, all right? Because 1 unit of Coke gives me 2 utils. Wow, 1 unit of Pepsi only gives me 1. In this way, if this were the case, 1 unit of Pepsi and 0 units of Coke, then my utility would be 1. In this case, 1 unit of Pepsi and 0 units of Coke gives me 2 utils. Wow, 1 unit of Pepsi only gives me 1. In this way, Then let me go ahead and all right. So a little typo on the slides, but this is more correct. All right. So now with this setup, we value 2 cans of Pepsi in the same way we value 1 can of Coca-Cola. For the reasons I just saw, 1 can of Coca-Cola and 0 Pepsi would give me 2 utils. Meanwhile, 1 can of Pepsi and 2 cans of Coca-Cola, I'm sorry, 0 cans of Coca-Cola would only give me one. So I need 2 cans of Pepsi to give me the same utility as 1 can of Coca-Cola. So in this case, I had it backwards in the beginning. In this case, you'd be a Coca-Cola fanboy. All right. Nonetheless, in general, the more general form of perfect substitutes is this right here. All right. It's still linear utility, but we have these coefficients in front. All right. The coefficients in front are we get a certain level of utility from consuming these things, and you can alter these coefficients to match whatever you want to consider in your model. So the general form of perfect substitutes, excuse me, is this linear utility function. Now, what is important here is remember we had this notion of marginal rate of substitution. All right. Marginal rate of substitution was you take, remember, this was du dx over du dy. All right. Remember the marginal utility of x divided by the marginal utility of y. How do we get marginal? Is to take a derivative. And then if we took the derivative of this function with respect to x, then we would simply get the coefficient a. We took the derivative of this function instead with respect to y, then we'd simply get the coefficient b. Remember, if I'm taking derivative with respect to x, and I just treat y like a constant. And what is the derivative of a constant? It's 0. All right. So if we do that, we see that the marginal rate of substitution for perfect substitutes is constant. I can always substitute the same amount, no matter how much I have, no matter how much I want. The marginal rate of substitution, the substituting one for the other, is always going to be the same amount because these things are perfect substitutes. The other type of extreme is perfect complements. All right. So consider ketchup and French fries. And just suppose that you like both. And so if you like both, then you will never have one without the other. For every one ketchup, I'm sorry, for every 1 unit of French fries, for every one order of French fries, you're going to need 1 unit, one small cup of ketchup. All right. You always want to have these two things together. All right. This is the notion of complements. All right. They complement each other. And so you consume these two things together. All right. We also have a function for this. We also have a mathematical function for this. The mathematical function for what I just described, the 1-for-1, is given by this right here. All right. It's a min function. Graphically, this looks like if this is qx, I'm sorry, excuse me. I want to delete that. This is q of y, and this is q of x. Then the min function, if you plug it into Desmos, looks something like this. That's not what I want. There we go. Is min. All right. So graphically, that's what the min function looks like. But maybe this is, well, let me point out. Does this min function look like something that would be easily differentiable or well behaved? Not quite. Not quite, right? Remember, if you remember from calculus, differentiability um, doesn't work if you have a vertical line. Because what is the slope of a vertical line? it's infinity or it's undefined. So it's not well behaved here. And then we also have this kink point, all right, a corner. This kink point, also derivative is undefined. Here, the derivative is defined and it's just zero. But in general, the derivative, the marginal rate of substitution of perfect complements is not really a well-behaved function. So we don't, that's why I didn't include this MRS stuff for the perfect complements, right? Because we don't really worry about it. All I want you guys to know and have down is that in general, the utility function for perfect complements is this min function, and the coefficients represent the same as we saw in substitutes. So maybe if instead, if this were French fries, if X were French fries and Y was ketchup, then maybe I only need one unit of French fries, but maybe I need like two little scoops of ketchup. Then it would be min of X comma 2Y. Write this cleanly. So what I was saying, like that, X comma 2Y. All right. This is a general form. All right. The coefficients correspond to the number of things that you want to equate. All right. So this is how we model perfect complements. Like I said, the MRS is not so well behaved, so we won't worry about it for right now. What I do want you guys to know is that the optimal consumption for perfect complements is you must consume them in ratios equivalent to what is given as the argument of this function. All right. So in general, if somebody has perfect complements, then they always want A times X of whatever good X is, and B times Y of whatever good Y is. All right. They always consume things in these ratios, proportional to these ratios. All right. Very good. Very good. So that was a slight detour. But this was just talking about some things that were mentioned at the end of lecture 3 that I think are important moving forward. Now, notice these are extremes. All right. This is one extreme. This is the other. I got one and I got the other. Most goods exist somewhere in the middle. All right. So maybe you have something like right here. This is what, if it's not a perfect complement or a perfect substitute, then it's somewhere in the middle. And sometimes you will see things, especially if you read the textbook, referred to as imperfect substitutes. So maybe that's a case of where something is in the middle. All right. But if they're perfect, then they're perfect and they're at the extremes. Very good. All right. So that that is some things that we saw in Principles of Micro. All right. That's how we get the downward sloping demand curves that we saw in Principles of Micro. And this gives a more formal mathematical basis for it. Let's remember some other things that we saw in Principles of Micro. All right. Let's remember one of the things I want us to recall now is elasticities. All right. Elasticity is one of the things you probably saw in the first half of your micro course. And the one that you saw was the price elasticity of demand, which is defined here as the percent change in quantity demanded with respect to or divided by the percent change in the price. All right. Mathematically, this looks like this. All right. Because this is the total change, or this is the change in quantity, and then you divide it by the original quantity. This gives a percent change. And then you do the same with price. Depending on where you took your microeconomics class, you also saw the midpoint formula. Midpoint formula for elasticity. What this means is that instead of delta Q over Q, dividing that by delta P over P, instead you saw delta Q over average Q and delta P over your average P. The midpoint formula, if you're gonna do if you're gonna do it without calculus, if you're gonna try to calculate elasticities with demand, elasticities, price elasticities of demand without calculus, then this is preferred because this will give us the same answer going both ways. All right, whether the price is going up or the price is going down, you calculate the elasticity using the midpoint formula and you will get the same number. Whereas if you use this version, then you will get a different number depending on if the price increased or if the price decreased. All right. But one way or another, the idea is the same. We wanted to calculate the percent change in quantity divided by the percent change in price. And that was the price elasticity of demand. Another way, we won't see this yet, but just as a preview, a third way with calculus is you'll take the derivative of the demand function. Remember, this is quantity demanded as a function of price. This is the demand function. And, oops, that's what I wanted. This is where the first formula comes from. Because truly rigorously, if we use calculus, then this is what we want to do. We get the instantaneous rate of change divided by the instantaneous quantity. Or you'll do D. If you just remember, we're dividing by fractions, so you multiply by the reciprocal. This is the most formal version of price elasticity of demand using calculus. All right. So this is good to know. It's good to know all of the different ways that we can express this one same idea. All right. I would, if it's ever on an assignment or an exam, then I will tell you which one to use. And yeah, so you don't have to worry about guessing or getting it wrong. All right. I just want you guys to be comfortable with the idea of what this thing represents. And then one last time, I harp on this because it's important that to understand that elasticity measures percent change in quantity when it's a measurement for change in quantity when the price changes. All right. We remember that intuitively this tells us about how sensitive a consumer is to price changes. All right. So if somebody's very sensitive to price changes, this usually happens in perfectly competitive markets, then they're elastic. Whereas if somebody's not very sensitive to price changes, if they're going to buy something regardless, then this is inelastic. We refer to this as inelastic. The canonical example of an inelastic good is a life-saving drug. So maybe insulin. All right. One of the terrible true things is that, for one, people with diabetes, they need insulin to live. All right. They need insulin to keep their sugar in check. So they must always buy insulin. No matter what the price is, they're gonna need it regardless. This is something that is inelastic because the insulin, the pharma folks, the manufacturers, these guys can raise the price and people are still gonna buy. They're gonna just have to deal with it, at least as much as they can. So insulin is pretty inelastic. All right. Insulin is pretty inelastic. This usually happens in imperfect competition, imperfectly competitive markets. Competition, which is equated with market power and price making, price setting behavior. But we also say price making because they make the prices. They don't take the prices. And if something is inelastic, if the price elasticity of demand for a good is inelastic, then the firm, the producer firm can increase profits by raising the price. All right. In contrast, if something is very elastic, in the case of something where when we have something more closer to perfect competition, this is usually like the market for foods. I have on here an example of fast foods, but most foods are generally perfectly competitive markets. In this case, firms are price takers, businesses are price takers. Why? Because consider like fast food, right? There's a ton of fast food around. Um, Even fast food restaurants of the same franchise, like a Starbucks in North Seattle versus a Starbucks in Pike Place, they can charge different prices for things. Will this affect revenues? It depends. It depends on the elasticity of the consumers in those areas. All right. Now, if there's a lot of substitutes around, if what you're selling is not very different from what the guy down the road is selling, then there's nothing that makes you stand out. This is more like a perfectly competitive market. And so you don't really have pricing power. You can't really raise prices because they're going to just go buy from the dude down the street. If this is the case, this is the case of elastic demand. This is the case of elastic demand. And when we calculate these numbers, we will find that the number, the fraction in absolute value, in magnitude, is greater than one. All right. Whereas inelastic means it's between 0 and 1. So it's going to be 0 point something. All right. There's a phrase unit elastic if it's exactly equal to 1. But if you call that elastic, I won't take points off. All right. But we should know that equal to 1 is unit elastic. And I just want to write here that firms, if demand is elastic, cannot raise prices without losing profit. I always remembered it as like what it sounds like. Rubber bands are very elastic. So elastic people are very dramatic. They're very quick to change up and go buy from somebody else. Meanwhile, inelastic means you're stiff. It means you're not going anywhere. And it means that you won't change up even if the price goes up. Because for one reason or another, you have to. All right. So that should all sound familiar. All right. We remember elasticity from Principles of Micro. All right. But there were also other elasticities. The general notion of elasticities in economics is pretty important. And we care about elasticities for many different things. One of the other ones that we like to consider is cross price elasticity. So how does the demand for one good change when the price of another good changes as well? All right. It has a nearly identical form. It shares the same skeleton. In fact, all of these elasticity formulas share the same skeleton. It's going to be something like this. All right. Here, I'm only talking about one good. Here I'm talking about two different goods, and I have to be specific about which one is changing in quantity and which one is changing in price. All right. But the core is the same. All right. The core idea is the same. We're going to take the percent change in quantity of one good and divide it by the percent change in price of another. It's always going to be a quantity on top. It's always going to be some dollar amount change on bottom. All right. This generalizes to all of elasticity formulas. All right. And then we should just know that if this cross price elasticity is positive, meaning that suppose the price of good Y increases. So if price of one good increases, people start buying the other good. This gives us a positive elasticity or cross price elasticity, and this implies that goods are substitutes. I should be more careful and say just substitutes. Meanwhile, if this is a negative number, then these goods are complements. All right. If the price of Y goes up and the quantity demanded of X goes down, then these goods are complements. And if it equals zero, if price of Y goes up and nothing happens to X, then these goods are unrelated and they're more than like they're orthogonal to each other. All right. They're unrelated, doesn't matter. All right. We need to be comfortable with the concept of elasticities because this will pop up throughout the course and even in this lecture, later on in this lecture. Great. Now, remember at the beginning of this recording, we saw a little bit about what happened when the price of one good changes. All right. We held income fixed, we held the price of the other good fixed, and we held our preferences fixed. We just changed, if there are four things going on, it's our preferences, our budget, and then the price of the two goods. So we have four things. We held three of them fixed, and we just changed the one. This is my ring finger, by the way. We just changed the one. All right. It was the price of a good X. All right. So now of them same four things, what if we leave the prices the same, preferences the same, and the only one thing we change is our income now? What happens? Let's consider this. Let's consider this. All right. The same thing we saw earlier is we're gonna pretend we have the same utility as earlier. And now just leave the prices the same. All right. PX is one and PY is one. All right. Good X and good Y, they both cost $1 each. And initially you have $12 to spend. All right. Then consider what happens if those prices are the same, but you have a greater budget. Consider specifically what happens if instead of $12, now you have $18 to spend. What happens? What happens to your budget curve? And then again, what if instead you have $24 to spend? What is your budget curve? What does your budget constraint look like? Take a few seconds, try this on your own. Make sure you can plot a budget constraint. All right, this is foundational knowledge. So take these few seconds to plot the budget constraint. All right. So you should have been able to do this. If not, I'm going to do this one for us, but this is really important. All right, so you better be able to do this. All right. So consider case 2. All right. So if the price rises to $18, then what do we do? Well, again, your intercepts are just your income over the price of whatever good of the axes that you're working with. So here, if it was $18, then we'd have 18 over 1. And so we'd get an intercept of 18 in budget curve 2. Likewise, it would be the same thing for this x-intercept. Of course, this also means that the budget line is going to look something like this. I can do this since I'm on an iPad. If you're doing pen and paper, just try your best to make it straight. It's your own notes anyways. And then I wanted you to label this as budget curve 2. Then I didn't state it on the text, but go ahead and label that first one as budget curve 1. All right. And if we do the same thing, but now instead of $18, we have $24 to spend, that's our new income, then we're going to call this budget constraint 3. What you should have found was that you'll have intercepts at 24 at y equals 24, and then another intercept at x equals 24. You'll plot those. You'll draw a line that connects those 2 points as best as possible. And this is exactly what we saw in an earlier lecture, right? In fact, I actually gave this answer earlier in lecture, not this one, but an earlier lecture before this, that an increase in income shifts the budget constraint, shifts the budget line outwards. All right. And I gave us the preferences here in yellow. I'm not going to have you do those right here, right now. I'm not going to do them in front of you. I'm just going to tell you that if these are the preferences in yellow and those are the prices, they've remained fixed, then now we're going to call this A. Yeah, this was the optimal point in the original. With budget curve 1, the optimal point, the optimal bundle was 6 and 6. If instead we go to budget curve 2, then we come to a new optimal point, which we're going to label B, and it would be 9 and 9. Again, if we did the same thing, we did the utility maximization problem, but instead now we went to budget curve 3. We call this C, and we plot this, and we find that the consumer would demand 12 and 12. This, if I were to draw a line through these 3 points, connect these points, this is the income consumption curve. Actually, let me erase this one right here. We can plot those 3 points and we can see how our optimal bundle changes. Let me just call it something else. Then we can see how our bundles change as our income increases. All right. If we were to then plot how the consumption changes with our income, let's go ahead and do that right here. So what I mean by that, when at y equals 12, let's just look at quantity. We like x, we like good x, so let's do good x. The quantity of x was 6. At y equals 18, quantity of x was 9. And at y equal to 24, the quantity of x was 12. Plotting these things, let's plot these points. Let's plot these as points. All right, plotting these points. Let's do income on the y-axis. Income. And let's do quantity of x on the x-axis. And then let me just go back really quickly. And I do want to call this line, this blue line right here, this is the income consumption curve. I just thought in my notes that I had referred to it as something else, but I did not. So I was right the first time. Don't second guess yourself. All right, this is the income consumption curve. It plots how consumption changes as income changes, how consumption, the optimal bundle changes as the budget curve shifts outwards. All right, but here, instead, I'm plotting income against the quantity demanded. So now, instead of the budget curve shifting outwards, I'm just putting income on the y-axis. Then, what can I do? Let's plot this first point. Y equals 12, x equals 6. So we'd get something like this, roughly something like this. More or less good enough. Maybe I'll move it just a little bit. And then when y is equal to 18 and x equals to 9, then I have something like this. Is pretty good. Yeah, that's where I want it. Oh, thanks. There we go. And then lastly, at income level of 24, we saw that the quantity of X demanded was 12. And again, you guys, the way I got these quantities was by solving the consumer's problem, the consumer maximization problem, the utility maximization problem. I just didn't do it here in front of you because I want to show you other things. But you can get to these exact answers and these exact bundles if you solve the utility maximization problem with this utility, these prices, and then the different levels of income. And that's how I get these points. So what I have here, if I were to connect these 3 points, then this red line here, this is what is known as the Engel curve. All right. The Engel curve plots uh, quantity demanded against income. Quantity demanded, or I guess I should say the Y value first. Plots income quantity demanded. All right. This is what is known as the Engel curve. All right. One thing I want to note is that because of the preferences I chose really easy ones. And the prices I chose very simple things. We got a straight line. The Engel curve does not need to be straight. There's nothing that says it is required to be straight. It's simply straight in this example because of the problem that I chose, the example that I gave. All right. We should just know that the Engel curve um, plots the demand against income or the consumption against income. All right. This is the Engel curve. One thing I want to note too, that the upward sloping Engel curve, this means that you consume more as your income increases. This is not always the case. All right, this is not always the case. Um, there's nothing that says the angle curve has to be a straight line. It's very much possible that you could see something like this. And you can also see a downward sloping line. All right. I'm going to revisit this in a few seconds or in a few minutes later in this lecture. But what we see here is that the angle curve slopes upwards. This is what happens in the case of a normal good. All right. But this need not always be true. All right. So that's what's known as the angle curve. Okay. Very good. Next, let's once again see how does demand change as the consumer's income changes. All right. So in this first picture, I have what we saw earlier in this lecture. In this first picture, I have income equal to 12, and I plotted um, the different cases for when the price of good X is equal to $1, $2, or $3. And just as we saw earlier, we had bundles. Let's make notes of what the points we had. We had bundles of, I'm going to say at px equal 1, q of x equaled 6, at p of x equal to 2, Q of x equaled 3. And then at P of x equal to 3, Q of x equaled 2. All right. That's what these points correspond to. If we did this same exercise for again, but now raise the income. All right. Suppose instead of $12, you have $18 to work with. Then what do we notice? Well, compare the two. We notice that the intercept changes just as we expected it to. Not just the y-intercept, but also the x-intercepts. Same thing, same thing, same thing, same thing. And if we were to work out the consumer's problem, the bundles that we would get, we would say that, let me just make a note up here also. When income equals $12, we got all of this right here. Over here, when income equals $18, what are the bundles that we have? Well, if the price of good X is equal to 1, then the quantity demanded of X is equal to 9. When the price of good X is equal to 2, the quantity demanded that you would find is 4.5. Finally, when the price of good X is equal to 3, then the quantity demanded of X is going to equal 3. And that's what these points here are. All right. So we have demands at different price levels. And we have in the blue is with the lower income of $12. Meanwhile, in the red is at an income of $18. All right. And remember earlier that we plotted the demand function. We plotted the demand function by plotting these points. All right. Let's go ahead and do that. Let's compare. What does the demand function look like when income is $12? And then let's plot what does the demand function look like when income is $18? Let's go ahead and do that. I've given us space to do that here. What I'm going to do is copy this, paste it here. At least I hope I can copy this. There we go. Paste it here, just so I can have it on my screen. And I copy this. I paste it here. That way I don't have to be switching back and forth. I don't have to be zooming up or scrolling the page up and down. I can just make things nice and easy. So these are the points I want to plot. All right, so let's do the blue ones first. All right, the first, and this is going to be exactly the same demand function that we saw at the beginning of this lecture. So at a price of 1, quantity equals 6. So we have price of 1, quantity equal to 6. And at a price of 2, quantity is equal to 3. We have something like that. And then, of course, we had at a price of 3, quantity was 2. And if we draw a line that connects those points, we get this first demand curve. We get D1. All right. Now let's do this again. but for the red points. All right, let's do this again, but when for the points which correspond to when income is equal to $18. All right. So when income is $18, then at a price of $1 instead of 6, we demand 9. When price is equal to 2 and we have $18 to spend, then the quantity demanded of X is 4.5. So we have something like this. And then finally, when income is $18 and the price of good X is equal to 3, then the quantity demanded is 3. So we'll have something like this. Here, if I were to draw a curve that connects these points, hey, let's get it a little bit nicer. I can do a little bit better than that. How about something like that? And let's erase. And then I also, just for purpose of exposition, let's go ahead and make these. Um, how about something like that? All right, I just want to make this clear. If you did it with the graphing calculator, then we don't have to worry about any of this. All right. Just taking a little bit of extra care because I want you guys to see the example clearly. So the blue one was D1. All right. Got a scholarship off for your D1. All right. And then this is D2. All right. So what did we see? All right. We held prices. Well, we plotted demand as price changed. All right. And this gave us the demand function. We see that graphically, geometrically, that as income increased, not the price increases. The price increases gave us the demand curve, the demand curve, but it was the income increase that gave us this demand shift. All right. Con Again, it was the income, the change in income that shifted the demand curve. Income increased, so the demand curve shifted to the right. What did we notice? We noticed that increasing income shifts the entire curve. The entire demand curve. Meanwhile, changing prices gives or yields movements along the curve, but the curve is fixed in place. So the income change shifted the entire curve. Meanwhile, price changes moved us along the curve. This is exactly what we should have saw in principles of micro, that a price factor, something we refer to as a price factor, aka the price of the good itself, that moves us along the curve. Meanwhile, this change in income, in other words, a non-price factor, is what resulted in shifting the curve entirely. This is kind of the one of the full circle moments that connects what we saw in principles of micro to how we can incorporate this into our mathematical models. This is exactly the result we want. All right. And it connects to what we saw, what we heard about in principles of micro. All right. This should be clear. If it's not, watch it again, watch it slowly. But this is a nice low speed, somewhat low speed derivation of how we get some of the results that were presented to us in Econ 200. But now getting it from math instead of just drawing the curves and just taking it to be true. All right, very good. Now, one of the last things I want to talk about, at least for this lecture, is the concept of normal and inferior goods. All right. Earlier, 2 slides ago, 3 slides ago, we saw this angle curve. And in this angle curve, we saw that as income increased, then so did our quantity demanded for whatever. And I called this a normal good. All right. I always liked to understand things as you have two types of goods. You have normal goods and you have inferior goods, or you can call them name brands. These are your brand name, your brand name goods. Or you have your generics. All right. Your generics are what you buy when you're low on cash. And what do we expect? We expect that for generic goods, we buy these more when cash is tight, when income is low. And if we get a raise, then we're probably going to buy more name brand goods and less generic goods. All right. This makes sense. This is something we all do in real life. We can also incorporate this into our mathematical models. All right. How do we do that? Well, we do it with elasticity. One of the ways that we can illuminate this idea is looking at it through the lens of an elasticity. So you can define what is known as income elasticity. Income elasticity is the percent change in demand and quantity demanded with respect to percent change in income. All right. This is why earlier I was careful to mention a dollar amount of something because this is a percent change in income. All right. So it's not the price of a good, but it's still on the denominator. A dollar amount is still on the bottom of the fraction. Meanwhile, a quantity amount is still on the top of the fraction. All right. Once again, all elasticity formulas have the same skeleton. So we define income elasticity as the percent change in quantity demanded divided by the percent change in income. All right. The income elasticity it tells us a lot of things. It tells us about all of the things that I've mentioned in this lecture. It tells us about does the angle curve does the angle curve um, slope up or down? It tells us the slope of the income consumption curve, and it tells us how will the demand curve move when income increases or changes in general. And firms care a lot about income elasticity when they're deciding what to do about prices when a tax increase happens. So, like, for example, um, suppose the state of Washington just enacted an income tax increase for a certain population. Doesn't matter what income level, just suppose they enacted an income tax increase. Well, a firm is going to go and hire an economist, an economic consulting firm, and say, hey, this is what I'm selling. This is the market I'm in. Can you tell me what is the income elasticity for this market? Because I know that maybe these people just got their taxes raised, maybe they just lowered their taxes, all right? But one way or another, the take-home income, the disposable income changed. The business will go hire the econ consultants and say, hey, can you do can you estimate what is the demand function for my market, for whatever I'm selling? And the smart econ folks, they'll say, okay, they'll look at some data, they'll wiggle some prices around, change some things around, and look at how things change with income. And they will estimate these elasticities, these different elasticities. This is what an econ consultant does, is they'll take a bunch of data of a bunch of transactions at a bunch of different prices for a bunch of different people, tons and tons of data. And this is why you guys that want to do economic research or want to do something related to economics in practice, uh, these days it's pretty much a necessary condition that you have some data skills. All right. These days you cannot do economics without data skills. Everything in econ relies on getting data, matching data to these numbers and formulas. All I'm here to teach you is how do we get the theory of these formulas, the theory of the things that we want to test and estimate. It's the next step in the process is to go and get data or have your work give you the data and actually estimate these things, actually compute these things, calculate these numbers from the data from what is going on in business transactions. All right. And then so the econ consultant firm, they come back to the business and they say, all right, given all the data we've collected and all the data you've given us, we've estimated these demand curves for this market. We've estimated all these elasticities for this market. And then the econ consulting firm can tell the business whether or not it would be a good idea to raise prices or lower prices. So if something is income inelastic, then it doesn't matter if that tax increase kicked in. You can raise prices and they're still gonna buy. Conversely, if something is income elastic, then they're gonna say, hold on now. These folks just dropped in income. Don't raise prices. That's not in your best interest. All right. You're going to lose profit. You're going to lose out on money, take home money, if you raise prices. So you need to be considerate of the tax increase. And then more generally, this is what an economist does. This is the type of value that an economist brings, is at least a business economist. All right. When it comes to other things, more of like the social science humanitarian side of econ, they do other things with elasticity. But this is just an example of how a business economist would work or how an econ consulting firm works. Is they're going to guide their consultants, right? So they're going to give advice, they're going to do their analysis, they're going to give advice to the firms on how they should price things. All right. The name of the game in econ is prices, is pricing, is cost benefit analysis. We're always considering what is the core of econ. We're always considering benefit versus cost, marginal benefit versus marginal cost. Or if it's a firm, it's marginal revenue versus marginal cost. All right. We always want to find that maximizing point, whether we're maximizing utility, trying to make ourselves as happy as possible, or maximizing profit, trying to make the business as much money as possible. All right. So that's a little tangent, little bit sidetracked there, but this is what an economist in the real world does because this is micro theory. All right. This is all pen and paper, consumers and suppliers and prices and whatnot. But it means nothing if we can't go out and apply it to the real world. And that is a short synopsis of how the real world connects to the theory world, how the empirics connect to the theory, and that's how these things come together. Anyways, nonetheless, let's get back to this last slide so we can wrap up for today. And this lecture will be a little bit shorter than is typical. One, because I think I went a little bit fast, so maybe watch this video back a couple of times. And then two, um, there is we are near the end of our consumer theory. I just have a few more things to say. I'm going to put it in the next lecture, and that will complete the demand side. And then we're going to start on the firm side. We're going to start on the whole supply side of things. All right. Anyways, let's just make sure the last thing we want to do is concretize the difference between normal and inferior goods. All right. So normal goods with these. you buy more as income increases. This means that the angle curve is upward sloping. Meanwhile, for an inferior, a generic good, you're going to buy less as your income increases. As you become richer, you buy less of this stuff. All right. And then this in this case, the angle curve is downward sloping. All right. The angle curve is downward sloping in the case of an inferior good. And on this one, I guess I should just make a small note that even if this income elasticity is zero, we still lump that into normal goods. So this one doesn't have a middle case. There's no unit good. It's just normal or inferior. All right. I believe that's all I want to cover in this lecture. Um, yeah. Yeah, that's all I want to cover in this lecture. There's, like I said, there's one last chunk of consumer theory that I want to get to. But I'm going to leave that for the next lecture, lecture 5, because I think it would run over the remainder of the time that I have for this one, what would be a 2-hour block. I think it would push us a little bit over 2 hours. So I think let's call it right here. Um, and then we'll finish up consumer theory in lecture 5. And from lecture 6, we'll start the firm side. We'll start the supply side of things, and we'll start to think about this profit maximization problem. All right. So, yeah, that's all I have for today. And I will see you guys for the next lecture. Thank you.